In this lesson of 11.1, we're going to be looking at circumference and arc length. So we're going to continue to look at circles, and we should be pretty familiar with what circumference is, but then we will translate that to being able to find the arc length. Before we did arc measure, arc length is we will actually know how long that arc is going to be. And so circumference, we should know it's the distance all the way around the circle. It's like perimeter, but for circles. They were able to find a constant of pi. So pi is about 3.1415. It goes on forever. It is an irrational number, but we can approximate it and use about 3.14, or if you use your calculator, it'll give you several decimals for it. And so then we're able to use the circumference formula, and so they were able to find it. It's just c equals pi d or c equals 2 pi r, just depending on what we are given. And so in example 1, we're going to find the indicated measure. For A, it says a circumference of a circle with a radius of 9 centimeters. Okay, so radius of 9 centimeters, so that means I need to use 2 pi r. So circumference is equal to 2 pi r. And so I'm just going to plug that in. So circumference is equal to 2 pi, and instead of r, I'm going to put in my 9. I can go ahead and multiply my number, so 2 times 9 is 18. So I would have 18 pi centimeters, and I can put in my label. Or I can give the approximation as well, so the circumference here would be approximately, and if you put this in, like I said, make sure you do it in your calculator, because it's going to give you a more exact answer, especially when we start to do more complicated problems, or even we have a much larger circle. Using your actual pi in your calculator instead of just 3.14 gives you a closer answer. So this would be approximately 56.5, and it would be 56.5 centimeters. In B, it tells us we want to find the radius of a circle. So we're still going to use c equals 2 pi r, because we're still doing radius. Okay, but now we need to plug in circumference instead. So we're not looking for c. We actually know c is 26, and so we're going to solve for our r. Okay, so to get r by itself, I'm going to divide by 2 pi. Okay, so that would mean that r is equal to 26 divided by 2 pi. I'm going to simplify that, and so that is 13 over pi. That's just 26 divided by 2, leaves that 13 on top. And so this would be meters. And then the approximation would be 13 divided by pi. Again, use your calculator. And so 13 divided by pi gives me approximately 4.1. And so then moving from circumference, we're going to use actually circumference to find our arc length. So arc length, we've been doing it in degrees, we've been measuring it, and so being able to find those measures was the first step, obviously. But then we can actually find the length using these formulas. There's many ways to write this formula, so if doing one of these ways, you're getting mixed up with what to multiply by and what to divide by, you can come and talk to me and we can kind of write it out in some different ways. But you can really use either one of these. Usually you use just this formula right here, that arc length is equal to the measure of the arc over 360 times 2 pi r. And so basically, what we're doing here in this middle part, where we have it, the arc measure over 360, is we're finding what portion of that circle are we looking for. So we're finding the whole circumference, and then we're going to say, well, I'm not looking at the whole thing, I'm only looking at this little part. Okay, so basically it gives you a percentage, and so you find the percentage of that circumference to get that arc length. So when we do this first one, we want to find the indicated measure, so we're going to find the arc length of AB. So AB, okay, is what we're looking for. So the arc is equal to the arc measure over 360. So we're going to do measure of the arc over 360 times the circumference. So times 2 pi r. Okay, so now I just have to plug these parts in. So my arc, AB, is equal to the measure of the arc. So the measure of the arc, well, if we notice this is a central angle here, so central angles, we just put it out on the outside for the arc as well. So I do 60 over 360 times 2 pi, and then our radius is 8. So then this one, basically, I just have everything's already on one side for me, so I can just put this in my calculator. Make sure you put it in correctly. You would have 60 over 360 times 2 pi 8. And so when we multiply all that out, we end up getting approximately, so I need to erase my equal sign, but approximately 8.4 or 8.38. You could do either. It doesn't say what to round to at the moment. So I'm going to go ahead and just do 2 decimals, so 8.38. And this one was measured in centimeters, so I'm going to put my label of centimeters on there. In B, we want to find the circumference, actually. So I'm going to write our formula just a little bit different. I'm going to still do it in the same order. So I'm going to do xy, the arc length, is equal to the measure of the arc, so the measure of xy, over 360. And instead of times 2 pi r, I'm just going to put c for circumference, because that's what that part is, right? Over here on the left, I could have just put c originally, and then I could have plugged in 2 pi r, because that's what c is equal to. So here I'm just going to leave it like this. So I'm going to start filling in my parts. And so here we have xy, right? We know the length is actually 4.19, so that's what I'm going to plug in here. So this is my 4.19. My measure of my arc, once again, I have a central angle, so I can put it on the outside as well. So this is 40 over 360, and then times c. And so I need to get c by itself, actually. So you can do this one of two ways. I was always taught to flip and multiply my fractions. If you feel a little bit more comfortable doing a decimal and then dividing by that decimal, that's all right as well, because we're already approximating in this one. But if you need to come and ask me for a different way to do it, or you're not sure, please come and ask questions, okay? So what I do here is I'm going to multiply by 360 on top, because that'll cancel out the 360 in the bottom, and then 40 on the bottom. So that's why I said I learned to flip and multiply fractions, and so I would multiply that on the other side as well. So 360 over 40. So here 360 cancels out with this one, 40 cancels out with that one, so I'm left with just c on that side. And then the left side, I just need to multiply it out. Okay, so I have 360 over 40 times 4.19. And so when we do that, we end up getting 37.71 as our circumference. Okay, so make sure here, if you need to, pause it to be able to write all that down, because I'm going to erase it. Okay, because I can't fit C over there on here. So, okay, so I'm going to erase this part. Okay, so on C, we want to find the measure of the arc. Okay, so again, I'm going to start the same way. The length of my arc, SR, is equal to the measure of my arc, RS or SR. I wrote it backwards there, I guess. If you want to write it in the same format each time, you can. So we could do RS here. So then the measure of RS over 360 times 2 pi r. Okay. So here, we know the length of RS, so the length is 44, so I'm going to plug it in. I do not know the measure, that's what we're going to solve for. So I have the measure of RS over 360 times 2 pi, and then my radius is 15.28. Okay, so I need to multiply that part out, is what I'm going to do first. So I'm going to do 2 times 15.28. And so when I rewrite this down here, I'm still going to have 44. I still have the measure of RS is what I'm solving for. And then I have times 30.56. And actually, I can multiply that by pi as well. So hold on. So I actually do 2 times 15.28 times pi as well. I can do all of it. And so this is times 96. point, I'm going to do 0.1, I'm going to do 2 decimals. And so now I can go ahead and I can divide that by the 360, or you can do this in 2 steps. You can divide by 96.01 and then multiply by 360. Entirely up to you. I'm going to go ahead and just divide it. So here I have 96.01 times RS, times measure of RS, divided by 360. So I'm just going to divide it out. It's going to give me a really little decimal. So I'm going to have 44 is equal to the measure of RS times 0.27. And so now to get RS by itself, I'm going to divide by 0.27. And so I end up doing 44 divided by 0.27. And so if I write this over here, I'm just going to do it over here. So the measure of my RS is approximately 162.96. So I'm just going to go ahead and do 163 is approximately what it is. Just because I would have done only 1 decimal here probably, and then it's going to round up. So it's going to be approximately 163 degrees is the measure of RS. In example 3, we're going to look at a real-life problem, so using circumference to find distance traveled. So here we have a car tire, and it says to the nearest foot, how far does the tire travel when it makes 15 revolutions? Okay, so we're going to use circumference first to find out how far does it travel when it does 1 revolution. Okay, how far is it all the way around that tire? So C is equal to 2 pi r or pi d. If you look, we can actually get the diameter because we have this whole length here. We just need to add it up. So I'm just going to do pi d here. So over here on the side, I'm going to do d is equal to all that added, right? So I would do 5.5 plus 15 plus 5.5 to go all the way across that tire. And so for my diameter, I end up getting 26. So when I plug this in, I get pi times 26. Okay, so 26 times pi gives me approximately, and I'm going to do 2 decimals here so that way we have a few more. 81.68 would be our circumference. So that would be, it would travel 86.8 inches, right? Because if you notice over here, these are in inches. Okay, so it goes 81.68 inches in 1 revolution. Okay, so, because that's just going all the way around the circle. So if it goes all the way around once, it goes 81.68 inches, right? So now we need to do that 15 times. Okay, so all I'm going to do here is I'm going to multiply this by 15. Okay, we know 1 time it does that, so if I do it 15 times, it's going to give me 1,225.2. And this is still in inches, okay? But if we notice in our problem, it says the nearest foot. So if we want to convert this to feet, I was always taught to put it over 1. And so my converting factor, I need to get rid of inches, so it needs to go on the bottom, okay? And to change it to feet, so now my inches would cancel. And so I know there's 12 inches in 1 foot, so that means I'm going to divide that by 12. So I get 1,225.2 divided by 12 would give me my feet. And so when I do that, I end up getting 102.1 feet. Okay, so when it goes 15 times around this tire, it's going 102.1 feet. In example 4, we have the curves at the end of a track are shown on 180-degree arcs of circles. The radius of the arc for a runner on the red path is shown. About how far does this runner travel to go once around the track, round to the nearest tenth of a meter. So for this one, we have 180-degree arcs. Okay, so that means if I look at this arc right here, if I go across, that means that arc starts there, ends here. It's telling me it's 180 degrees. And actually, I can go straight through the middle, right, because it's 180. So it goes straight through where they say is the radius there, basically. So if it's 180 degrees, that means we're talking about a half of circle, right? A semicircle. So I'm going to be able to find circumference there, but I'm going to divide it by 2, okay, right? So circumference is typically 2 pi r, but right now we're only doing half the circumference for that circle, right? So I would go ahead and divide it by 2 in order to solve it. So here, we're going to divide our circumference by 2. And then I can't change my formula, so I would actually be dividing by 2 on both sides. So we're doing half a circle, right? And so it's the circumference over 2, I'm going to erase that, and I'm just going to say we're doing a semicircle. Circumference of a half a circle, basically. So I'm just going to write it. It looks kind of like a D. I'm trying to draw a half a circle there. So what we're doing here, so for that side, for that one arc, I would have 2 pi, and then our r is 36.8 over 2. So I can multiply that all out. So for the circumference of this first arc, okay, so for this arc on the left side, we would end up getting that it's going to be 115.6. Okay, so that would be the length here. So I'm going to write it over here, 115.6 meters. Okay, and then for the other side, we do the same thing. It's a half a circle again, so I'm just going to use the same formula as well. Okay, so I have 2 pi r over 2. Basically, if you notice, the 2's cancel, and we just have pi r. So pi r, I would have pi times 44.02. And so when I do that one, 44.02 times pi is going to give me 138.3. And so I want the whole distance all the way around. So this is 138.3 meters. Here I have, down at the bottom here, I have 84.39. That would also be the distance on the other side. 84.39. And so we just need to add it all up, and that will give us how far they travel when they go one time around. So I just add all my parts. So my 115.6 plus my 84.39 plus 138.3 plus again another 84.39. And it wants nearest tenth of a meter, so when they go one time around the track, it's going to be about 422.7 meters. Okay, I know this video is a little bit long, so just bear with me. This is the last slide that we look at. So converting between degrees and radians. So know how we've been changing our calculators. We need to make sure it was in degrees every time. They didn't say RAD at the top. Radians is another type of measurement, and it's used a lot with circles. And so we need to talk just about being able to convert them right now. Okay, so if we want to convert from degrees to radians, we can multiply by this standard here, either 2 pi over 360 or pi over 180. So that's when you're going from degrees to radians. If we want to go from radians to degrees, then we do the opposite. We flip it, okay? So when I set this up, I always do to make sure the right thing's going to cancel, okay? Because I don't want to multiply by radians again and make it radians squared, right? That doesn't get rid of radians. That just squares it, okay? So when I convert this first one, I want to do 45 degrees to radians. If I'm doing 45 degrees over 1, I want to get rid of degrees. So degrees needs to be in the bottom. So that means I'm going to use the one where it's pi over 180. Okay, so when I do that, so now I can just do 45 times pi, and then I'm going to divide it by 180. I could get an approximation by doing it that way. So I would get a decimal. But the way that we want to leave radians instead, okay, if you notice in the second one, a radian is written with a pi in it. And so we actually don't multiply the pi. We're just going to multiply it across. So I'm going to do 45 pi over 180. And so I just need to simplify this fraction part, okay? So I want to do 45 over 180, but I want it simplified. And so when I simplify that fraction, and whether you just put it in your calculator and do math fraction, if you know what to divide it by, okay, that's up to you. It's going to simplify down to be 1 over 4. So that means that this answer here is just pi, okay, because 1 pi, I don't need the 1, I can just do it as pi over 4 would be my answer for A. Okay, so 45 degrees in radians is pi over 4. So now if we look at B, we're going to do the opposite. We're going to start with a radian. So we have 3 pi over 2. Okay, and this is in radians. And so I want to multiply where radians is now in the bottom to get rid of it. So radians needs to be in the bottom. And that means I would want degrees on top. So that means I'm going to do pi on the bottom. And so that 180 is on the top. That's this one here. Okay, so when I do this, my radians cancels out, and so I'm going to be left in degrees when I finish this. If you notice, my pi's cancel, and so all I have to do is just multiply across now. So I'm going to have 3 times 180 over 2, and so when I multiply that out, I end up getting 270 degrees.